All right, in sections 1.7 here, we're going to take a look at finding perimeter, circumference, and area of just a few different figures, all of which really you should be familiar with. Just a quick reminder, or refresher I should say, perimeter is the distance around a figure, okay? Namely around a polygon. We talked about polygons in the previous section, and so now we're looking at perimeter. And then area is the amount of surface covered by a figure. How much two-dimensional space does it take up? All right, so in a square, okay, if I want to know how to find the perimeter and area of a square, now I'm going to tell you two different things here. First of all, for the perimeter of a square, you could acknowledge one of two things. The first is that all four sides are congruent. We knew that, okay? So you could say the perimeter is S plus S plus S plus S, or obviously the shorter way of writing that is just 4 times the length of a side. As for the area of a square, you can think of this as two different ways. One is you can recognize that a square is a rectangle, and so you could do base times height, or you could recognize that the area of a square can just be found by doing the side length squared. Again, whatever formula you want to know or memorize is completely and totally up to you, okay? The perimeter of a rectangle, again, in a rectangle you could recognize that this side, if those opposite sides are congruent, and so these opposite sides are also congruent. And so for perimeter, you do L plus W plus W. In other words, you just add up all of the sides. The book will talk about a formula, 2L plus 2W. Again, this 2L plus 2W will be nice in certain instances. So you should have that in the back of your mind, but you don't necessarily have to use that formula when finding perimeter. Okay? And then to find the area of a rectangle, you just do length times width, base times height, same idea. A triangle, if you look at a triangle is half of a rectangle, okay? And so to find the perimeter of a triangle, right, we just add up all three sides. There's no special formula for a triangle. And then for the area, a couple different ways to think about this. You can do 1/2 base times height. Again, we just said it's half of a triangle. Or you can do base times height divided by 2. Both of those represent the same thing. Again, I know I'm going quickly, but it's understood that you already have a foundation in these ideas or with these ideas. Circumference is the distance around a circle. I always tell my students circumference is a fancy word for the perimeter of a circle. Okay, circumference is the perimeter of a circle. So when we're working with a circle, we can talk about circumference. The way we find the distance around the circle, or the way we find circumference, is using the formula 2 pi r, or that's the same thing as pi times the diameter. Should make sense because if I sketch in the diameter here, right, this is r and this guy's also r. So 2 times r is the same thing as d. And then the area of a circle is just pi r squared. Just note pi is a number. Okay, it's not some variable, it's not some unknown thing. All right, it is a number. The diameter of a circle, I sketched it in already in the other circle, but the distance across the circle is the diameter. Okay, so it tells you it's we have a rectangle here and we want to find the perimeter. So I could do 2 times 27 plus 2 times 78, or I could just do 27 plus 78 plus 27 plus 78, same thing. This is 54, 156, and finally when I add those two things up, it's 210 feet around the perimeter of a circle, or I'm sorry, of a tennis court. And then the area of the tennis court, right? A equals base times height. That's 27 times 78. And 27 times 78 is 2,106 square feet. All right. So again, very basic problem involving perimeter and area of a rectangle. So it says the smallest circle on an Olympic target is 12 centimeters in diameter. That's 12. Find the approximate circumference and area. Okay, so C equals 2 pi r. The radius here is, obviously, if the whole thing is 12, then this is 6 and 6. So I have 2 pi times 6, which is 12 pi centimeters. You could plug that in and get a decimal if you so desire. I prefer just to leave pi in my answers most of the time. Okay. It's important to note, if it says approximate, that's saying give me a decimal. You can give me a decimal, it's okay. If they say exact, you got to leave pi in there, okay? The area of a circle, right, is pi r squared. In this case, our radius is 6, so that's just 36 pi square centimeters. Again, if you'd like to plug in for pi, you can, but not 100% necessary, So what I'm going to do is I'm going to go ahead and turn you guys loose here to take a look at these few examples here on your own. I think you have a pretty good foundation of what's going on. So if you have issues on these, just bring those to class and we'll go over those first thing. So we will look at these last two examples though. Okay, the base of a triangle is 24 feet. Its area is 216. Find the height. Always start with your formula. A, 1/2 base times height. Plug in what you know. I know capital A is 216. I know the base is 24. I want to know the height. So you have 216 equals 12h. Divide both sides by 12. And so the height of your triangle is 216 divided by 12, which is 18 feet. Okay? Again, it's an area problem, but you're just solving for something different, one of the components. Okay, the area of a triangle is 96. Its height is 8 inches. Sketch the triangle, label all parts, find the length of its base. Okay, so here's your triangle. All right, height, that guy is 8 inches. And then we just know the area is 96. That's all we know. Okay, 96 square inches. It says find the length of its base. Here's B, right? There's the base. So A equals 1/2 BH. Plug in what you know. 96 equals 1/2. I don't know the base, but I know the height. So it's 96 equals 4B. Divide both sides by 4. The base here is 24 inches. So again, I feel like this is probably a section that should be pretty easy for you, should be primarily review. But again, if there are issues with this section, please have questions ready, and we'll take those first thing.